This is a video on Laplace transforms. Number 1, the Laplace transform of 1 is equal to 1 over s. Number 2, the Laplace transform of e to the at is equal to 1 over s minus a. Now, we're going to use formula 2 to derive formula 3. The Laplace transform of e to the at times sinh of kt is equal to the Laplace transform of e to the at times the quantity e to the kt minus e to the negative kt divided by 2. Okay? Now, I'm going to pull the 1/2 out in front, and I'm going to distribute the e to the at inside these parentheses. Now, when I do that, I get 1/2 the quantity, and then I'm going to take the Laplace transform of e to the a plus k quantity times t minus the Laplace transform of e to the a minus k, that quantity times t. And so over here you can see I just rewrote that. And on the next line, we get 1/2 the quantity, 1 over s minus, in parentheses, a plus k, minus 1 over s minus, in parentheses, a minus k. And again, I just used formula 2. So this is 1/2 of 1 over s minus a, that quantity minus k, minus 1 over s minus a, that quantity plus k. So you can see I just distributed the negative inside to each term within the parentheses. And then I grouped s minus a together. Okay. Now from this third line here, we're just going to do a little bit of algebra. And so this is 1/2 of s minus a plus k minus s minus a minus k, all divided by s minus a plus k times s minus a minus k. So if you notice, when we simplify the numerator, we get 1/2 of, and now in the numerator we get 2k, in the denominator it's a difference of squares, and so we get s minus a squared minus k squared. The 2's cancel, and we get k over s minus a squared minus k squared. And we're all set. So it says the Laplace transform of e to the at times sinh of kt is equal to k over s minus a squared minus k squared. And on number 4, suppose we want the Laplace transform of e to the at minus e to the bt over a minus b. So this is 1 over a minus b. That's a constant, that's fixed. And we're going to take that and multiply by the Laplace transform of e to the at minus the Laplace transform of e to the bt. So this is 1 over a minus b times 1 over s minus a minus 1 over s minus b. So again, I just go back to formula 2. That's what's literally happening. And so we get 1 over a minus b times the quantity, and then if I get a common denominator, I get s minus b minus, and then in parentheses, s minus a, all divided by s minus a times s minus b. Next page. So this is 1 over a minus b times a minus b over s minus a times s minus b. Notice how the a minus b's cancel. And we get 1 over s minus a times s minus b. I'm done. And then the Laplace transform of e to the at minus e to the bt divided by a minus b is equal to 1 over s minus a times s minus b. And then I saw another formula, and then we'll call this number 5. Now, suppose I want the Laplace transform of 1 minus cosine of kt. Well, this is the Laplace transform of 1 minus the Laplace transform of cosine of kt, right? Now, recall, and we derived this formula in another video. The Laplace transform of cosine of kt is equal to s over s squared plus k squared, okay? Therefore, the Laplace transform of 1 minus the Laplace transform of cosine of kt is 1 over s minus s over s squared plus k squared. Okay, and if we go to simplify that, we get s squared plus k squared minus s squared divided by s times s squared plus k squared. So what you're doing here is simplifying rational expressions, okay? And the s squareds cancel, and we get k squared divided by s times s squared plus k squared. Therefore, the Laplace transform of 1 minus cosine kt is, if we go back, we get k squared over s times s squared plus k squared. So you can see it's really, really, really nice. And I see a lot of formulas on this formula sheet or this table for Laplace transforms. I see probably 15 formulas that solely rely on these first two formulas. So if you know that the Laplace transform of 1 is 1 over s, and the Laplace transform of e to the at is 1 over s minus a, you can probably reason out close to 15 or more formulas just off those two. And that's what I want to convey in this video and in the previous video that I did make. Okay, thank you.